Hi, this is Mrs. McTaggart, and in this video we're going to look at the last couple of graph transformations and some kind of past paper style questions. So we're going to look at these types of occasions here where you have a number in the front, when you have a number inside a bracket in front of the x, and when you have the inverse function. So the first one is when you have a number in front of f of x, and it could be positive or negative. The effect that number has is it stretches or compresses the graph vertically. And the best way for me to illustrate this is think of your sine graph. Now your original sine graph is the one in red here, and it goes from 1 to -1. You know from previous experience, the minute we stick a number in front of that, for example a 2, a 3 or a 4, it stretches that graph vertically and it gets taller, doesn't it? So your turning points move up or move down. Okay, if you double the number in front, you double the height of the graph. If you quadruple the number in front, you quadruple the height of the graph. That's what's going to happen with these ones. Similarly, if you put a half in front, you half the height. And you can see the three examples here in red, blue and green of your 2 sine x where it's stretched vertically, and the half sine x where it's compressed vertically. So we're going to look at some like that. Okay, so here we have a very basic graph drawn, okay? And this graph has the name y equals f of x. I'm just going to put a random number on there. So all we know about this graph is that it's got a turning point at -1, 2, and it's got another turning point here at 2, 0. Now we have to draw on top of this the graph of y equals 3f of x. Now what's going to happen is this is going to stretch it vertically this way. All your y coordinates are going to multiply by 3, okay? So it's going to be your y coordinate only that changes here. So I'm just going to write that up there. Okay, so your y coordinates are all going to multiply. So this -1, 2 is going to become -1, 6. So it's going to maybe come somewhere up here. Okay, this turning point here, 2, 0, that's not going to change though, because if you multiply your y coordinate by 3, it's still going to be 0, 0. So all I'm going to be drawing is a taller looking version of this graph. Now the roots are still going to be the exact same, so it's still going to go through here and it's still going to touch there. Because remember, picture your sine graph, it still has all the same roots, it's just the turning points that kind of stretch. And this one here at 2 is not stretching anywhere at all because it's already kind of on the axis. So let's try and draw this, and I apologise in advance because my drawings are generally shocking. So it's going to look a bit like that. Oh, and that's not even reached. Right, let's try again. And I swear this is even harder for me to do in class. Okay. Right, so you'll have to forgive me and make sure that looks like it's sitting on the axis a wee bit better. Okay, so there is my new diagram. It has just stretched. Now, last thing to do is mark on my new turning points. So this -1, 2 is going to now be at -1, 6. Okay, because the y coordinate has multiplied by 3. And one last thing to do is label that is the graph of 3f of x. Okay, let's have a look at another one. Okay, so here is my next one, and we have another one here. So this is the graph of f of x. We have to sketch this time 2. I'm going to sketch the one where it's got a 2 in front and the one where it's got a half in front. So the one with the 2 in front is going to stretch my y coordinates and it's going to double them. So the 3, 4 will now be up here, and that will be at 3, 8. And the 3 minus 2 will be away down here, and it will now be -3, -4. Okay, and I'm going to do my best to draw this shape. Now all your roots will stay the exact same because they are all x is 0, y is, so let's draw the diagram. I'm going to try my best here. So I'm going to take it slowly. I'm going to do the curves first. So that's definitely not as bad as my last one. So here's my new diagram, and I already have the coordinates marked on, and I'm just going to label that was the 2f of x graph. Then I've stuck in another one here. We wanted the half of x graph, so that means all your y coordinates are going to half. So your turning point here will be at 3, 2, and I chose numbers that would half, and your turning point for this one will be at -3, -1. So it's just going to look a lot shorter for this one, and actually a lot easier to draw. Okay, and I'm just going to label the green one as your half f of x. So that's what's happening when you have a number in front. You're either compressing it or stretching it vertically. And honestly, the easiest way to think of it is think of your sine graph. Okay, so it's stretching your y coordinates. The next one we look at are the ones where the k is inside the bracket in front of the x. So the effect it has in this one, and hopefully you don't get asked this one because it's not there often. Now there's a wee mistake in my spelling there. That should have an R in the word there for stretches. So the effect k has stretches or compresses the graph horizontally. So that means left to right. And again, think of your trusty sine graph. The red one here is your basic sine graph, okay? That is the one that goes from 0 to 360. And if we asked you to draw the graph of y equals sine 2x, that would be the blue one, it would suddenly finish at 180, wouldn't it? So what's actually happened there is all our x coordinates were halved. So doubling the x actually halves the x coordinates. So it affects the x coordinates on this one. The other one we just did affected the y coordinates. This one affects the x coordinates. And it does opposites, okay? So a 2x in the bracket halves them. But then if I do a half x, it doubles them, okay? So bear that in mind, and if you have any doubts, come back to that sine graph all the time. So here is an example. This is a graph of y equals f of x. We have to sketch the graph of f of 2x. So all my coordinates here, the x coordinates, because it says 2x, the x coordinates are going to be halving on this, okay? I'm now fitting what would effectively be 2 within that one space. So let's have a look. I'm going to do a bit at a time. So I'm going to move the 6. So the minus 6 halved would be 3. So that would be at minus 3. The negative 4, 3 would now be at negative 2, 3. This turning point is 0, 0 is still going to be the exact same, okay? So what I've got now is I have this shape here. So it has halved in width. So that is the graph of f of 2x, alright? Next one I've got is this one here. I just need to change my colour because obviously it's already in red. Right, so this is, I think this is a power 4 graph here. So we've got a turning point and then we have, it's not the clearest, but there's a point of inflection up there. On this graph, we have to draw the one of g of half of x. So remember, your half one is the one that actually stretches it out the way. So this one is going to stretch that. So all our x coordinates are going to double. Now this is a bit tricky to fit me in because I haven't picked the best of numbers here. However, 2, 3, if you double the 2, that will now become 4, 3. So I'm going to put 4, 3 there. And that's going to be like your point of inflection shape going through there. Alright, so I'm just going to draw that in. The turning point minus 2 will come to here, and that will be minus 4, minus 2. Now, I'm not going to be able to fit the coordinate in here, so I'm just going to do this and put that there. And then where it would have cut at minus 4, it's now going to cut at minus 8. So I need to have this kind of shape coming from here. Still going to go through 0, 0, and then it's going to go over here and have a wee point of inflection there. So that is my shape, and it's not the best, but I'll just fix it a wee bit. Okay, and last thing to do is double check you have labelled all your coordinates. I've got my new route, I've got my 2 turning points, so it's kind of gone double in the width of that one. Okay, and the last type of graph I need to show you is the graph of the inverse function. Now the inverse function, this is the easiest one to get me for me to show you to explain. The inverse is always the opposite, and everyone agrees that the opposite of doubling is halving. So that is the inverse of each other. And here is the graph of y equals 2x. When we first teach you gradient, like way back when, what that means is that is going along one box up to all the time, along one up to, and so on, right? The inverse of that would be going along 2, up 1, along 2, up 1, which is what gives you the gradient of 1/2, because it's 1 over 2. So they are the inverse of each other. And if you look at them, it is symmetrical across this dotted line here, which is y equals x. Remember, y equals x is your most perfect line that goes perfect diagonal, an angle of 45, and that's where it's got all the coordinates of 1, 1, 2, 2, 3, 3, etc. So when you come to drawing the inverse, we're going to draw in that imaginary line and think of it that way, okay? Okay, for this one here, we have to sketch the line of 2x plus 4. We have then to find the inverse mathematically, and then we have to sketch it. So finding it mathematically should also prove that the inverse sketch works. So the line of 2x plus 4 is a line with a gradient greater than 45 degrees and a y-intercept of 4. So I'm just going to draw what I think would be a suitable line, if you bear with me. So a suitable line would be something like that. So that's definitely steeper than a gradient of 1, and all I have to do is mark on that that is a y-intercept there of 4. Okay, so this would be f of x. Then what I'm going to do is I'm just going to put in my dotted line. So there is the line y equals x I'm going to flick over. But first of all, just a wee reminder of how do you find the inverse. So the inverse, to find the inverse function of f of x equals 2x plus 4, you write that as y equals 2x plus 4. You then change the subject so it's x equals, so you're going to have y take away 4 equals 2x. You're going to divide by 2, so you're going to have y take away 4 all over 2 equals x. Then you switch the x and the y around, so that gives you x take away 4 all over 2 equals y. And then that means that your inverse function is the x minus 4 all over 2. Now I'm going to just split that up, okay? And I'm going to say that that's a half x take away 2, okay? Now if I was to sketch the line of a half x take away 2, that would be again an upward sloping line, but it wouldn't be as steep. And its y-intercept would be negative 2, all right? Now if I sketch that kind of line, so not as steep as the other one, it would go a bit like that. And that would be at minus 2. And this would be the graph of inverse x. Now can you see that that isn't kind of mirrored in that, cutting the axis? And where you would find where this line cuts here on the x-axis would be substituting that, putting that equal to 0, you would have a half x minus 2 equals 0. You would have a half x equals 2. Double that, you would get x equals 4. So that would be there. All right, so the bit where it cuts on the x-axis would be the number 4, which is what's mirrored here. Okay, so just to show that actually has looked like the mirror image of the one we started with. So here is another one where the x cube's already drawn, so we have to draw the mirrored image for that one. So the mirrored image is just basically tilt the screen if you want, right? It definitely helps. I can even do it on here to show you what I mean. So tilt the screen if you're struggling to draw a mirror image. Turn it your line of symmetry is up and down the way, because that's what you used to do in first year. And then draw your line. So you're just drawing a wee mirror image of this here. So you're making that kind of lovely leaf shape. Now, mine is not wonderful, I'll be honest with you. Look at that. And then what I'm going to do is I'm going to turn my screen back, straighten it up for you. There is your perfect mirror image. Now the inverse of, so this is the, oopsie daisy, sorry. So this is the graph of the inverse. Now the inverse of x cubed is taking the cube root x. So that is what that one is that we've drawn there. However, they don't ask you to draw the inverse very much. But what we're going to now is, we have some past paper style questions, okay? Now, this one here wants us to draw on separate diagrams. So we're going to draw this twice over. So what I'm going to do is, before I start drawing on it, I am just going to duplicate my image, right? So I've got the benefits of being able to do that. Now, the first thing they want us to draw is the graph of f of x plus 3. So that's what I'm going to do here on in blue pen on the first one. So on this one here, I'm going to draw the graph of f of x plus 3. Now that is the one where it's just moving up 3, okay? And on this other one, I'm going to draw the graph of negative f of x, which is the one where it flips up and down, okay? Now to do this, I definitely think it helps to make my picture a wee bit bigger, so that's what I'm going to do. So this graph here, we're going to move it up 3. So we've got a root already at 0, 0. If you move that up 3, I think that's a suitable distance to say is 3, about there. So that's where my new turning point is going to be, at 3. The coordinate negative 2, 4, if you move that up 3, that's still going to be a negative number, so somewhere about here will be my minimum, and I'm going to say that that is 2, negative 1, because minus 4 moved up 3 is negative 1. And then I'm just going to draw the shape in. This is the bit where I seem to always mess up and don't have the best diagrams. So that would go like that. Okay, and then I've got all my coordinates marked on. I've got my turning point 0, 3. I've got my turning point 2, negative 1. Then they had a coordinate 3, 0. So all I'm going to do is mark on where that would be now if it's shifted up, which is 3, 3. And it's just always good practice to remark any coordinates they gave you in the first place just in case. So that is a graph moved up 3, right? That's the easy one. Next, we have to draw the graph of negative f of x. So that's the one where you've got to flip it up and down. Negative in front means it goes upside down, because remember, there's your x squared, there's your negative x squared. So it's flipping upside down. So basically, easiest way to do it is it's like doing a symmetrical picture, or think of where all your important points are going to be first. If you flip this, that becomes a minimum there. And then at 2, negative 4 flipped up means you're going to be a maximum now. And that would be at 2, positive 4. I can't quite fit that in because of my writing up there, but we'll put it at the side. So that would be 2, negative 4. And I'm just going to draw that in. And it's still going to cut through that one there at 3, 0. So there is my diagram. I don't need to remark the 0, 0 one, but I have marked that one up there as 2, negative 4. So this is a graph of negative f of x. So just flipping upside down, all right? And then I'll pull that back out so we can see the two together. Okay. Here's another one. So in this one, what I don't like about this one is the way that they set it out. They ask you to sketch a graph of 3 minus f of x. I think it's much easier if I rewrite this as negative f of x, and I put the positive 3 in the other end. From there you can see that that flips up and down, and then it moves up 3. So that's 2 steps we have to do. Now I would never ask you to do the 2 steps all in one go, unless you're super confident. So what I do in class is I do a red dotted line, right? And I do the flip first of all. So the first thing I'm going to do is just with my dotted line, I'm going to sketch in the kind of flipped graph. Can you see that there? And then what I'm going to do is that dotted line has to then be shunted up 3. Now at the moment on this dotted line, this is at 3, negative 2, right? When you shunt that up 3, that negative 2 will become positive 1. So I'm going to have a wee turning point in about here this time, all right? And it's going to be very difficult for me to label this because of the size of my diagram, but I can stretch it, so hold on. So that there will now be at the coordinate 3, positive 1, all right? And then my maximum turning point was at 0, 0, but that's going to move up 3. So this would have to be slightly higher than the 3, 2, so that would be about there. About here, sorry. So that's what I'm going to draw. So I'm going to draw, for some reason I'm coming from the right this time. It would look something like this. Okay, so that has been flipped and shunted up. Other thing I have to just mark on is that this turning point now is at the number 3. And I've got my turning point there of 3, 1. If you can't fit it in, you can always draw arrows pointing to it if you're struggling. So that is that one. So again, yeah, use a dotted line and use a pencil, and then you can rub it out if you want to. But I would never try and do it in 2 steps. Some people might want to move it and then flip it. I just like flipping it first. Let's look at one. Okay, let's look at this next one. So on this diagram, we have to sketch. It says in separate diagrams, right? Okay, so before I go on, I'm just going to duplicate that image so I can use that again for part 2. Okay, part 1. We are sketching the graph of negative 2g of x. So that means we are flipping it and stretching it, okay? Negative means flipped upside down. And then times 2 means we've stretched it by 2 as well. So I'm going to quickly just draw in a wee red dotted line for my flip. Okay, and my flip would make this at 7. So if I double everything, there's still going to be a minimum turning point here. It's still going to cut at 3, 0. But this maximum is going to be stretched away up here, and this is now going to be at the number 14, which I'm struggling to just fit in. So here we go. There is your new graph. There is your graph of negative 2g of x. So I flipped it with a dotted line, and then I've drawn it stretched double in height on that one. So all your turning points kind of stretch. This one doesn't move here though because it's already sitting on the axis, so that's not going to stretch at all. Right, the second one they want us to draw is the g of x minus 4. So that means everything is going to move 4 in the positive direction. So everything is going to move 4 to the right. So I'm just going to move everything a wee second to fit this in. Okay, so everything moving 4 to the right. This isn't so bad. So minus 6 moved along 4 will now be at minus 2. 3 moved along 4 will now be at the number 7. 1 negative 7 moved along 4 will now be 5 negative 7. So let's put that there. And then we just have to draw that shape again. So in terms of diagrams, this one was not too bad. Okay, so yeah, my line's a wee bit shaky, but you can see what I'm doing there. Okay, so that is the graph of y equals g of x minus 4. And you can see why they wanted us to do that on separate diagrams. Okay, let's look. Okay, this one here wants us to sketch the graph of negative g of x minus 2. So we are flipping it up and down. So it's going to flip that way, and then we are moving it 2 in the positive direction, so we're going to move it 2 right. So let's just think where the flip's going to be first of all. So I'm going to put in a little dotted line for my flipped graph. Okay, now I'm going to take each coordinate and look at that in turn. So the minus 5 moved along 2 will now be at minus 3. Okay, so it's going to be coming up to there. The turning point of minus 4 moved along 2 will now be at minus 2, so this will be here. So that will be at negative 2, positive 3. Because the minus 3 is flipping up the way and the minus 4 is being moved along 2. That's a wee bit messy, but I'm hoping you can see what that says, that it's negative 2, 3. The negative 2 moved along 2 will be at 0, so it's going to cut at 0. This turning point down here at the moment is 1, negative 5. So if we move that along 2, it's now going to be at 3, negative 5. So that would be 3, negative 5. And then when you turn that up, that's going to be moved along a wee bit. So the 3 moved along 2, it would be 5 there as well. So that is your graph of negative g of x minus 2. So flipped and moved along. Okay, last one to look at. This came from the 2018 past paper, and it said on separate diagrams sketch these two graphs. So this one here where it says 2 negative h of x, please rewrite that. That's negative h of x plus 2. So they want us to flip it and then move it up 2. Okay, so I am going to draw my dotted line for the flip first of all. So the flip looks a bit like this, and we've got a wee point of inflection going on there, right? So a point of inflection and a maximum turning point. We're then going to move them both up 2. So the minimum was at minus 5. If you move that up 2, it's now at minus 3. Still going to cut through here. It's going to look like that. So this is 3. Your point of inflection is at 2, negative 2. If you move that up 2, it's now going to be here. So your point of inflection is now on the axis at 0, 0. And there is no other numbers to have to mark on for that one, so that one's already done. So that is the graph of 2 negative h of x, so y equals. So that's that graph drawn. The second one wants us to draw the graph of y equals h dashed x, so that means it wants the graph of the derivative. So the graph of the derivative, whenever I draw this, is I draw it directly below the original one. So I'm just going to put on a wee set of axes down here. Oops, I didn't mean to move that. So there is an x and a y axis. That will do. Okay, so wherever you have a turning point on your graph becomes a new root. So we have got a turning point here at 0, 5. So at 0, 0 we have a root. We have a turning point here at 2, negative 2. So at the number 2 we have a root. So there's your first step. Just trace down where your turning points are. Then you look at the graph. Anything up to this turning point, your graph is increasing, right? So when it's increasing, you draw it above your line. So between there and there, it's above, okay? Between 0 and 2, your graph is decreasing. So between 0 and 2 and your new one, decreasing means you draw it below. So it's underneath. And then after the number 2, it's still decreasing, so it still gets drawn below. So that means that must have been a wee point of inflection there at the coordinate of 2. So there is the graph of the derivative. There is y equals h dashed x. So I hope you followed that okay. I know it's been a wee bit messy. I do apologise. But generally these are okay. It's a nice wee 3 marks if you can understand them and do them. And just remember the different connotations of the changing the equation. So thank you. Good luck.